Hello everyone, welcome back to my YouTube channel. For today's video, we will discuss about volume of revolution by cylindrical shells. So let us first know what is cylindrical shell. Cylindrical shell is a solid enclosed by two concentric right circular cylinders. So this is what a cylindrical shell looks like. In finding the volume using the cylindrical shell or the shell methods, we will be using two formulas, this one and this one. If the cylindrical shell is rotating in y-axis, we will be using this formula. V is equal to the integral from a to b 2 pi rh dx. If the cylindrical shell is rotating in x-axis, we will be using this formula. V is equal to the integral from c to d 2 pi rh dy, where r is the radius of the cylindrical shell and h is the height. So if the cylindrical shell is rotating in y-axis, the radius and the height should be in terms of x. And if it's rotating in x-axis, it should be in terms of y. For further understanding, I'll illustrate how these formulas work. But first, I want you to remember this rectangle shape here, because we will be using that in our illustration later. So we have a Cartesian plane here. This is the y-axis, the x-axis. Our cylindrical shell is rotating in y-axis. We have a curve here. The limit of integration is from a to b. The rectangle shape should be drawn parallel to the axis of rotation. And in our situation, the cylindrical shell is rotating in y-axis, so it should be drawn parallel to y-axis. The distance from here to here is the radius, and here to here is the height. As you observe, r is parallel to the x-axis, so we have r is equal to x. A typical cylindrical shell has a radius of x if it is rotating in y-axis and y if it is rotating in x-axis. What a typical cylindrical shell means is it is rotating at the center, or y is equal to 0 or x is equal to 0. So there might be changes in the radius if it is not rotating at the center, or x is equal to 0 or y is equal to 0. And our height is the given equation or the curve in our illustration, this one, that is the height.